Well, hi, good morning, and thank you for joining me in my shop here. It's the 7th day of October 2024, and on my bench is a very complex radio, an HRO 500. This would be from around 1960, 1962, I don't know exactly, somewhere in there. The thing about this is the follow-on transistorized version of the earlier tube version of the famous HRO radios. So I'm lucky to have acquired this one. I don't know anything about it on two levels. I don't know its history. I don't know anything where it's been, what it's been doing, yeah, or its current condition. I really don't know. It doesn't work. I can tell you that much. And the second part, I can't remember what I was going to say. So now I've been working on this radio a little bit, not doing videos on it, just to make it work. It's really been my goal. I've got a number of these classic great big communications receivers. I'm very excited to have them. Each one of them is coming with difficulties and problems, and that need to be sorted out, and my first step is to make the radios work okay, and not try to restore them to perfect operation by any means. Just make them usable so I can get some use out of them and gain experience in operating them. All these big radios I've got, they all have different sort of operating characteristics. This one is really weird. And I'll try to explain this, and I may have it wrong because, again, I haven't been able to operate this radio completely. It hasn't worked, as I'll be demonstrating. What am I doing with it today? Today I'm going to try to make it work. I have a scheme in mind which I'll explain and will become clear in a few minutes what it is I'm going to try to do. The weirdest thing about this radio is this synthesizer tune knob here. So this big dial has got a 500 kilohertz range. So if this radio is going to tune, this just feels fantastic, by the way. If this radio is going to tune its range, its complete range, it's going to have to do it in 500 kilocycles chunks. So if you're going to go all the way from below the AM band right up to, I don't know, 30 megahertz in 500 chunks, that's a lot of chunks. In a typical radio, that would mean many sets of coils and a big switch on the front here snapping through them, and there would have to be a ton of coils. It's just impractical to try to do that. So if you want this long range, super precise tuning knob thing happening on your radio, you got a big problem, because how are you going to do that without introducing huge numbers of coils? Well, here's a way. What if you could somehow, instead of using coils and snapping through them, what if you could synthesize the frequency you were after, and then use that synthesized frequency as the base for the operation of the radio from band to band to band? You don't have to switch coils necessarily. So how they've done it exactly, I don't know. But the way this works, and I could power this up. If I powered this up right now, all that would happen is this red light would come on. This is a red light here. It would come on. Turn this knob. Some stuff will come up in here. You can kind of see a little bit on the camera. And when you get this close to the right spot, this light will start going out. And when you get this on the perfect tuning spot, the light will go out, and this will tell you the base of this tuning range. What frequency the base is. You can't see it, but it says 19.5 right now. So you'd adjust this until the light went out, and then you'd be 19.5 plus whatever this is. This is 330, so it'd be 19.5 plus 330 would be 19.830. That's where you'd be tuned. Yeah, it's a lot. It's a lot. There is some band changes here. Okay, it's hard to see, but there's a mask moving across here, and there's a series of numbers arranged vertically, which move when you turn this knob. I wish I had better lighting, but I don't right now. Okay, rest of this is kind of typical of a radio, so I'm not going to go into any kind of discussion about it. This is the weird thing here. This thing in this light. So when I operate the radio and I tune this to the appropriate spot, the light dims a bit, but it doesn't really go out. And there's never any sound coming out of the speaker or the headphones. Nothing. When I got the set, there were two damages to it. One was the jack here was smashed inside. That part's had actually broken off. In either it wasn't making contact with the headphone, or it had even developed a short in here. Could have developed a short in behind here. On the back, the connector here, which I'm not going to take this off. It has an extending connector on it right now. The original connector was smashed. I think maybe something had been on it like this, and pow, or they put the radio down, or done something. Anyway, smashed it right off. So I don't think I have the debris here to show you, but I managed to replace that. It was extremely awkward putting this in. It's still a little bit loose. Who's that? It's still a little loose here, so the single wire soldered inside may come off at some point. Here you see two connectors connected to the 12 volt input, which I'm about to start explaining, and we're going to look at the schematic, and then I'm going to try to make this thing operate or find out why it won't. Now I have a cat down here. Yes, cat. Would you like to go in the garage? You want to go in the garage? Well, I think that's a yes. So I'm going to go put him in the garage. He was outside just now. She was outside just now, but it's a little cold. It's very cold outside. Okay, a little more talk. You might notice now there's a AC power cord in here, and I'm just going to pull these off now. So this thing can be operated from a plug it in the wall, or 12 volts can be fed into this. You see these are bent over. I've straightened them out a little bit. They're bent right over. Probably what happened to these is what happened to this thing. Somebody probably set this down on its back, or who knows. There's a lot of outputs on here. Of particular interest is this. Each one of these is a wire is connected to a wire, leads into the radio somewhere, and picks up something. In some cases it's just voltages. So you can poke in here and you can read different voltages. And I have a chart, which I may or may not have. I have it here. So this is the connector here. And this shows all the different voltages that should be there. With the set powered up on the AC cord, I tested the voltages here. By the way, we're going to turn this on with the AC cord in a moment. I tested the voltages in here. They're there, but they're all low. So there should be like a 12 volt, it's actually 10.7. There should be an 11 volt, it's actually 9.2. And onwards, down like that. So they're all about 15% low. Is that a problem? I don't know, 15%? Is that going to be a problem? Well, the radio doesn't work, so maybe it is the problem. So I'm going to, alright, I got to hook up the speaker here before we get too far. Again, I've never heard anything come out of the speaker or the headphones. No hiss, no pop, no click, no nothing. Nothing whatsoever. So I'm pretty sure what we're dealing with is was I saying something? Well, I'm not pretty sure of anything. What we're dealing with potentially is a blown output transistor. And why would that be? Well, it could be that headphone jack shorted out the output for a while. And you know what happens when there's no volume on a radio like this? You tend to turn it up and up and up. And perhaps that happened, and perhaps it got turned up on a short circuit, and that was the end of that. So that's a speaker connection there. The other thing is I'm the person who replaced the headphone jack. Headphone jack's a simple thing. It has a switch built into it. You plug in the headphones, it cuts off the signal to the speaker. Did I get it right? Knowing me, there's a good chance I got it wrong somehow. So I'm going to flip this switch to where it says 117 volts. So if you switch it here, you're powering from there. If you switch this down, you're powering from here. So we're going to power from there. And what else do we need? We need an antenna connected. Not that it's going to work, but I have been fooled before. I have started working on things that weren't working, and suddenly they are. So let's just see if that'll happen here. So then I can't do it with this. This is the wrong connection. Wrong connector. I've got just the connector I need. Right here. You know what? I gotta do this differently. Just trying to figure out the easiest way to do this. Give me a cable. No cable handy. Okay. As usual, when you try to do something the easier way, it turns out to be the longer way. It's one of the most frustrating things for me in life is when I try to undertake a shortcut, and the shortcut fails and it ends up taking longer than the original long way would have been. I find that really upsetting. I get really upset with myself. And I don't want to break the wire inside. That's not good enough. Okay, we'll put this on the antenna here. Okay, let's see what the radio can do. You notice I didn't say let's hear it, because I don't think we're going to hear it. So I went through a slow process of startup some time ago originally with this radio. So, you know, because it's not working and I don't know anything about it, I've been very cautious with it. This switch, the function switch, it has an off setting down here, and it's set to AM. It's not set off right now. This switch doesn't feel good. It just, I don't know, doesn't feel too good. So we're gonna leave it on. AM, volume down, and RF gain. So they've got the audio here and the RF gain. We can leave the RF gain up. The audio I want it down. Here we go, power coming on. Why didn't it come on? Oh, it did come on. Barely see the lights here. This light is on also. I don't want to darken it in here. We're feeding with 112 volts. That's plenty. Okay, I am going to have to darken it because you have to see that phase lock light. There, that's a little bit better. So first of all, kind of dull, huh? Don't you think? These are all lit, barely lit. Power supply problem already? So I will tune this adjustment now, and if you watch these things happen, you'll see this light flicker a little bit. So there it's bright. Now it's dull. It's quite distinct in the camera. And then bright again. Now I think it's supposed to be a very sharp spot where it's down, and then that should tell you that the oscillator in here, I don't know what to say exactly. It's set for 9.5 megahertz and above. I'm not sure how else to say it. I think this light is supposed to go right out. It's not just supposed to go bright and dull. It's supposed to go right out. But it never does. Go out. Now number 2, we'll set it here. So supposedly something is working right. We'll turn the volume up. Volume is full. RF is full. I don't hear anything. We'll look for crackles on the band change. Nothing. So this sort of seems to work. Like it's trying. But the whole time there is nothing coming out of the speaker, and if I put headphones in here, there's nothing coming out of the headphones. I mean nothing. There's no hiss, no pops, no clicks, no hum, no nothing. Which is a bad sign. Okay, now we're going to look at the schematic. We're just going to study the power supply because it's a whoppingly complex machine. Study the power supply. I'm going to show you something, and then we're going to try a trick and see if we can trick this guy into working. That's the idea. When he's not looking, we'll trick him. Here's the HRO schematic. Not quite sure why it's in two pieces here. The power supply area is located up here in the top right corner. That's where we're going to zoom in and take a look at. But I think I'm going to take a look at this bottom thing. What is this down here? Schematic diagram. Well, I'm not sure what this is, but we're not going to worry about it. Up here, you see schematic diagram, receiver. Okay, power supplies in this area. A little bit bigger. There we go. Okay. So what makes this power supply a little bit complicated is the fact that you've got switching to switch the DC supply on and off. So you have a 12 volt DC, alternate DC supply here, or you're feeding it in with 120 volts here. And this switch, which I think is set in the I'm not sure what they're doing here. Shouldn't this be over here? This is sitting in the DC position. Oh, this is also okay. So I guess I have it in the DC position in terms of the switch on the back of the set. Like the switch you saw me flip on the back of the radio is this switch and this one up here. And they're showing it in the DC position on this schematic. So in the AC position where I have it now, this switch would be over here on AC, and this would be also switched down to here on AC. So after the transformer, you have the two diodes. I suspect there's a problem here, but I don't know. And then you've got this voltage regulator scheme here with the transistor trying to hold the voltage. We have a 12 volt Zener diode. Now, remember I mentioned the black connector on the back had all kinds of outputs. Here's some of the outputs that you could find back there. These voltages, these are the power supply voltages that are supplied into the radio. If you start at the bottom here and look at the 12 volt one, you can trace it back, and it's literally right off the power supply, or if you're doing the DC thing, this is quite important, it's right off the input here. So the 12 is straight through. You can put it that way. Everything else is padded down or zenered or something like that. So if we follow back up here, we see a resistor 20, I think it's 22 ohms, 1 watt. It's a very small resistor, but that's what you would get in a power supply if you're trying to drop voltages. You do it with something like that. So off that resistor is 11 volts. And if you go forward a little bit, we have a filtering thing happening here. Another 22 ohms there and 10 volts. And if you follow this leg, you come over, you run into a Zener. And that Zener is a 7.5 volt Zener. And then off the output of that Zener diode is another Zener diode operating here at 5 volts. When I actually measured these with it plugged in the wall, I don't get 12. I got 10.7 here, and everything subsequently reduced, as if the supply voltage was low coming out of here. I was very disappointed. I'm not sure, is it too low? I mean, it's low. Is it so low the set doesn't operate? Is that why it's doing what it's not doing? Or if this were proper, would the set operate? Kind of doubt it, but I then just like a lightning bolt in my head, wait a minute, this does have a 12 volt input. Let's see how they do that. So when you flip the switch on the back of the radio to DC, you cut off the transformer entirely, and you flip this switch from taking the output on the other side of the transformer to just coming straight back to here. Now they do have a diode in here just to make sure someone like me doesn't hook the power up backwards and blow everything sky high. So there's a diode here. So they put 12 volts here, and they show 12 volts here, but there's a diode dropping, what, 0.7, 0.8 volts here. I have power supplies that are nominally 12 volts, but they're actually 13.8 volts. That's very common. And I was tempted to hook one up here, but I got chicken because it says 12. But you probably could hook up a 13.8 supply here and not really, it's probably just fine. But I don't know. I don't want to try it. I had enough trouble right now. It's not working. So I came in here last night all excited. I'm going to power this thing from the 12 volts. I hooked up the 12 volts. I set the switch. I did everything. And when I turned the set on, nothing whatsoever happened. Nothing. No, the red indicator light didn't come on. The panel lights didn't come on. Nothing came on. That's a mystery to me. So that's where I am, and that's where I'm going to pick it up today with you. From this point forward, we're going to try to make this thing work on a 12 volt supply, or find out why. It looks to me like it's something simple. Yeah, that's good. Something simple, eh? Okay. Coffee time here. Now, perhaps I did something wrong last night when I tried this, so we're going to try it again. First, the AC out. Okay, and the DC. For instance, these clip leads may not have been fortunately, there's a negative and a positive marked right on here, so pretty hard for me to get this wrong. And this is going to go into a heavy duty power supply I have right over here, whose voltage is set to, let's be sure. I'm going to disconnect one lead, turn on the supply here. Okay, and then we're going to read the voltage. There's a cooling fan in there in case you can hear it. We'll check now and see what the voltage is here. So it's just under 12. That's perfect. Hook this up. The radio is switched on right now. So as soon as I hook this up, we're in operating mode here. The volume is halfway. Now there's an ammeter. You can kind of just see a bit of it here. Nothing whatsoever. Yeah, I think nothing whatsoever is what's going to happen here. Oh. I mean, these could even be broken just in behind. Maybe the wire's off. Okay, so power's connected. Now we can flip the switch here. That's what we need to do. And you still see no current flow, but that's an amp meter over there. So it's so look at the front of the radio. No lights, and again no sound. Nothing happening whatsoever here. So that's where I'm at. You are now up to speed with me on this radio and its failure to operate. Okay, let me disconnect this before we have something bad happen. Okay, turn this off. Let's look at the schematic and we'll pick off the 2 or 3 most likely things that are happening here. Just zoom in another step. So we're supplying power in here. One possibility, this may be blown. The switch may be defective here. The switch here, this is switch S6. So S6, S6. So this switch should have flipped, and we should have had power coming right right through here, right to the lights. This dial lamp switch is closed because we had the lights on earlier. So I know the switch is closed. But no lights came on. Well, that's a powerful indicator that nothing is getting out of this connector. It's either this or this. We got to get in at this and take a look at this situation. Maybe I'm lucky. It's nothing more than the diode or wires broken off the back here. Okay, that's good. That's what I'm going to do. We'll open this thing up and try to get at this connector. Okay. Right, I have to take off all these 8 screws here, and then I think there was some underneath too that have to come out. Okay, I'm gonna take the radio out of its cabinet. Let's have a little look at this fantastic receiver. So National, so this was built by a company called National. National built a radio in 1935 called the HRO, which became and still is a classic radio, an excellent radio. Designed in the day where Morse code was the thing. And so the radio is designed around the idea of receiving Morse code, which means very, very narrow bandwidth and stuff. They achieved it with tubes, and it's a big radio, and it became very popular. Was the HRO was the radio that Britain used to get themselves through the Second World War. I'm sure there were other radios too. The thing about it, though, is of course it's made with vacuum tubes. So National, around probably in the 50s, decided, wow, they're going to have to come up with a transistorized version of this fantastic radio. The part of the radio that really makes it stand out is this dial. Even on the 1935 radio, they have a dial just like this. Well, not exactly like this, but very, very similar to this. So the National company wanted to maintain that look. This is what was setting their radios apart. So they designed a radio around this knob. That's part of it anyway. That's why I came up with this weird arrangement for band switching. So we look back here again. One of the interesting observations about this radio, this is National's first attempt, as I understand it, at a transistor radio. Maybe it's the first attempt at an HRO replacement radio. All these transistors are in sockets. They're all in sockets, okay, not the output transistors, but these other things are all socketed. All the transistors are socketed in here. That's very unusual. Of course, transistors are soldered in place. Look at all the ones up in here. That could come with a problem of the transistor not making contact in the socket, just like a vacuum tube could. Don't know if that's really an issue or not. Another possibility, which happens with tube radios, is somebody pulled the transistors out and stuck them back in the wrong spots. I don't think that's very likely. I think it's extremely unlikely. But it has happened with vacuum tubes. I'm just looking down. My eye just caught something of interest. If you look down in here, you see a plate with a whole bunch of cut marks in it. I think that plate is intended, it's a capacitor plate. It's intended to be some kind of master adjustment on this whole capacitor here. I don't know what it is actually, but it's just interesting. It's cut so many times so you can move little sections of the plate, like do plate bending, I guess. Now, I understand this to be a triple conversion radio. I said that to a friend of mine. He said, what? No. I've never heard of such a thing. But I think this is a triple conversion radio. Yikes. That's a lot of converting. And how many IF cans do you need in a radio? Oh my gosh, look at them all. Holy smokes. That's a lot. And then through these holes here, there are adjustments all through here. It is a busy, busy radio. What a monster. Inside these big heavy boxes are electronic components that I guess are being shielded like crazy. Like this one says synthesizer, harmonic generator. Synthesizer harmonic generator inside this box. This is a box here. Some kind of IF in here, I'm pretty sure. These would be the amplifiers here and the IF cans, and there's a crystal. There's a number of crystals in this radio. Oh boy, oh boy, oh boy. But what I'm really concerned about now is just behind this jack, what is going on. So we're going to take a look at that. Gee, can you flip this radio right over? Well, what happened in here? Huh. Is it the same on the other side? A little rough over here too. Very rough down here. It's like they've taken folded metal. Yeah, and they've welded it. It looks like welding, in fact. They've welded it into a solid can. Oh, a little hole there. Wow, that's pretty extreme stuff here. The other thing that's really kind of funny about this radio, it's a transistor radio, but it weighs 35 pounds. Those two things, they don't go together normally. I don't know that it's 35, but it's a lot. Okay, we're going to flip it over and look at this thing. I think I can flip it right over. It'll sit here. Got this weight. Well, we'll see. Maybe it'll, I don't know. We'll see what it does. That's really, really solid stuff. Whoa! Whoa! There's a lot of stuff under there. Oh my gosh. Holy smokes. Oh my gosh. Look at it all. Wow, they didn't hold back on this one. Holy smokes. Okay, not to be intimidated. I find this extremely intimidating. Look here. And they very neatly placed a piece of paper here, specifically so we cannot see what's going on down here. Why? Come on. Can I just pull this out? Stick it back in? Not really. Oh, come on. Here's the switch. So maybe I get the other camera. We'll try looking up this way. See if we can see in there, or it's going to have to be mirrors and stuff. Now I think the automatic focus is on this camera, so okay, we can see the back of the connector. Wiggle it a bit. Oh, the wires are hooked up. One of them looks uninsulated. This one here looks uninsulated, and it looks like it's heading for a short trip to the ground. That's the one that would break. Okay, so we can see this way too. I'll probably have to stop and turn off the automatic focus here. I haven't got enough fingers. Okay. That one. There's a short wire running down to what looks like a solder spot, a terminal or something down there, and that could easily be loose. The other one's got a long wire on it, so it almost certainly hasn't broken. Oh, it's got a loop in it and everything. Got a stress release loop, excellent. The other one, no, is short. It's the one that could break. Where's it going? Where was it going? It was going to ground, was it not? If it's going to ground, I don't even need it. Let's go back and look at that schematic again. So this is just going to ground, so I don't even need it. So all I need to do is positive here, negative on the chassis. Negative onto the chassis. Yeah, these are all chassis connections. I'm sure they're all over the place. Okay, and I don't see any other ground symbols anywhere. Maybe right at the front of the radio. Oh, so these are two voltages, these arrows. And no, we don't see any other kind of ground symbol. Okay, so that's got to be the chassis. So I'm going to hook it up power again on the assumption that the negative is broken here, but the positive is still good. Oh, we'll try this again. Let's see what happens. Okay, can I leave the radio upside down? No, I think I want to have it in a normal position. Okay, more adjustments down here. Another adjustment in there. Oh my gosh, there's just adjustments everywhere. There's one here, there's a bank of them in here, there's a bank here, a bank of them in here. Oh, wow. I hope I just put power on and it works. That would be good. Okay, flip this thing without losing control of it. There we go. Okay, the power supply is switched off. This negative we were just going to put on the chassis. A nice spot to hook up to the chassis. Give me a nice spot. Is that nice? Nice enough. Okay, the positive one around, go on the positive side of this terminal. Okay. Should I bother putting an antenna on it? Because I've heard nothing out of this, out of the speaker or headphones, it really suggests there's a lot more wrong in here, but maybe not. And speaker. Oh yes, we need the speaker on there. Ground connection here. Check those when I get it spun around. Looks okay. Volume down. RF up. We're on AM. Lights are on. Bandwidth wide. Boy, that's hopeful. Rejection tune set to off. If I hit the switch, the set comes on. Because I have this set. I have to reach across to do that. So I don't want to reach across, so I'm going to disconnect the clip lead here. I'm going to turn on the power supply. Okay, anybody happening here? Oops, I missed. Still see no lights. Okay, I'm connected. Oh, scared the heck out of me. So that sound just now is just my power supply fan coming on, or I don't know really what that was, to be honest with you. Is that protection coming on? No, there's a light over there that would come on if the protection had come on. Just a coincidence. So so I have the power hooked up, and I've definitely hooked it on the positive. I have the negative here. Let's just do a voltage check. So we're going to just do chassis anywhere, I'm going to try to touch the tang on the connector at the back. Chassis anywhere, chassis anywhere. Touching just the connector. And there's the voltage. So there's no question voltage is getting to that connector. The lights are not coming on. What am I not thinking of? There's not much else on this to... Well, if the lights are not coming on, the diode, there's a diode in the circuit. The diode is the only other thing. No, diode's not in the light circuit, is it? Schematic. Let's look at the schematic again. Yeah, the diode is in the light. I don't have to look at it. The diode's in the light circuit, so the diode is blown. Diode blown. Okay, power off. Disconnect. Okay, diode blown. You gotta find the diode and do something there. So I looked at the service manual. There's a diagram, shows the bottom of the radio and identifies many of the parts, but not the diode that I'm after. So if we look at the connector, just right here, you can see a white wire down here. Let me point at it. I have to trace that wire. I'm afraid it goes right into a bundle. So the wire I'm talking about is coming off the back of this connector right here. Here it is. Does a funny loopy thing here. And disappears into this, or underneath or through this bundle. I think I see it. The white wires right here. It might be. No, it disappears into this bundle. Goodness knows where it goes from there. So in this radio, they use a lot of these cards that they mount a lot of components on. And you know, like there's a diode right there. It's not looking too healthy, but I don't know if you can look at them and tell anything. There's all kinds of these capacitors all over the place. Yikes! There's a pile of diodes. Where did I see it? 1, 2, 3, 4 diodes over here. It would be a fairly big one. Yeah. Okay. I'm really at a loss here. How could I possibly do this? The diode's hooked up to something. Maybe I don't know. I have to go drink coffee. I have to go get groceries anyway. I'll go get groceries and not worry about this right now. Okay, well, I'm back from grocery shopping and I got an idea while I was out. What I've done is I've hooked up my ohm meter here to the black lead is hooked up to the positive pin on the jack on the back. And all I got to do is just check the diodes I can see and see if any of them reports a 0 on here. Then I could be on the other end of the wire that's going from the terminal. I will have identified the diode. That's the idea. So looking for diodes now. So there's a bunch over here. It's got a red wire to it. And I should really check this and make sure it's working. Yep. I would think this would be a fairly large diode. None of these look like they qualify. And nothing showing up. Okay. Over here. This is the diode I was suspicious of. It's got yellow wires coming to it, not a white wire. Nope. Well, from there it gets a little more difficult because where's more diodes to test? that are down in this area. Hidden away in here somewhere are diodes. These are signal diodes. I can't imagine they would use something like this. They look like signal diodes. What about on this board here? No. Did I miss any here? No. Do I see any more? So I'm gonna probably stop the camera and I'm just gonna have to hunt for a diode or try to find something I can touch with this and get a 0 on here. Right now I got a 0. Okay, well, poking around, I believe I found something here. I got down to the idea that the white wire goes into this bundle of wire here. Maybe I can spot white wires coming out, chase them down to the other end, and then test the far end. Actually, I'm just following another one right now over here. So there's a white wire here, and it goes to the main on-off switch right here. It's a 4 terminal switch, because I think it's switching the AC and switching the DC independently. So there's a white wire right here, and if I touch it, I get a 0. So the white wire appears to be going right from the terminal here, without a diode, straight to the back of this switch. Now, the radio's switched on, so the switch should be closed. So I should be able to find it again on another terminal. Maybe this one, maybe this one, maybe this one. Maybe this is the problem. Remember I mentioned the switch is wonky. When you work the switch, it just doesn't feel right. And it's reminiscent of my experience with other switches of the sort that on the back of volume controls typically, but in this case it's on the back of a band switch. It feels like one of these when they're bad. So when I work the switch, let me just make sure of its setting here. It's set to, yeah, it's not on. I mean, it is on. There's no on setting, so we'll just go, I don't know what to do. What do you do? I mean, if it's not working, it's not going to start working just because there. Hear that snap? I think that was the turning it off. Yes, that's the turning it off snap. That was snap should have come out of here. Sure sounds good. That sounds plenty good. Doesn't feel terrible. One of these should do it. This is off. So the next question would be, well, if the switch is bad, why don't I jumper it and get the set operating? Could the bad switch also be somehow implicated when I'm using AC? Not very likely. It's kind of a go, no-go situation. Not necessarily. Switches can make weak contact, they have dirt in them, but they would be terribly inconsistent, and you could work the switch and clear it away, and that's not the case. So what am I muttering about? So I'd want to figure out on the back of the switch which wire is going where, which one I should jumper to carry it on. So the challenge would continue. As for the diode, is it in here? I don't even know if it's in here. But considering I can get a resistance reading here of 0, that kind of suggests, actually, no, I got this up on 6,000. Let's put it on 600. I think I have trouble with this meter at 600. Let's check the 0. 0.5. 0.5. So it would appear there's no diode in that line. It goes straight over to the switch. And then the switch, well, it's got colored wires on it. Okay, so I'm going to stop and study the schematic, see if I can sort out how to proceed further yet. Okay, I thought of this. If it's a defective switch, there's actually two switches in here, one for the AC side and one for the DC side. I don't know if the AC side even works. But what we can do here is we can look for the AC switch, which should be shorted and closed now. And if I can find that, it should not be shorted and closed. All these wires. What's happened here? All tangled up. Okay, think now. So I can flip the switch to AC. How's that help? That doesn't help. That doesn't matter. It's all about this switch. The switch is on. Two of these things should be shorted. Let's just take a guess. It's these two. It's not exactly shorted, is it? So maybe this switch is a bad actor more than I realized. So an attempt at a short there. Other connections should show nothing. Nothing. Just these two. So if these two are shorted, now if I open the switch here, turn the set off. Okay, that supposedly is off. These things should be open now. They're open. So that means these other two, this is the one to short. If I want to carry on. I could put the switch on. I should find a short on the AC side. And we should also find a short on the DC side. It's open. That's pretty convincing to me. Why wouldn't I just short these two things together, feed in the DC, and I'll tell you why. Because I haven't given enough time to think about this. So I'm going to stop and give a little time to think about it. Okay, I have shorted the two pins that I think are the broken switch. So using this clip lead, and I hope I can turn this radio over again. And about how to do this. Go this way. Okay, and down. There we go. Okay. Now, my power supply is switched off. Put this back on ground. Put this back on the positive. Okay, it's definitely this one here. Good. Okay, there's a good chance the radio is going to come on this time. Power supply is set to the proper voltage. I have to move back a little bit here. If I flip it on and something terrible happens, what do I do? I'd be reaching way over there, so I don't like that idea. So what I'm going to do is rotate it this way. I'm going to pull the clip off the back, turn on the power supply here. Okay, so as soon as I make this connection, then the radio should come on. So we have volume is down. We'll turn the RF down too for no good reason. This switch is set so the lights come on. Okay, what's going to happen here? Okay, a light tapping. Ooh, I saw the lights. I saw the lights. Okay, so now let's just check the voltage here. Make sure we're where we think we are with this guy. 11.8 volts. Okay. Let's let her rip. Okay, I'm just going to clip it on. Boom, she's on. I'll tell you something I noticed right away. The lights look brighter, at least from back here. I want this clip to short out. Oh, it's really close to shorting. Very, very close here. I don't like the situation. My power supply has protection, so if it did short out back here, it wouldn't really matter. Well, as long as the protection worked. Okay, so I put a little tape on there, I feel a little better. What do we got happening here? Oh, I think for sure this is brighter. Okay, RF up, volume up, nothing heard, phooey, nothing at all. Okay, change bands, listen for a crackle, no crackle. Phase light is behaving, no, it seems to behave better than it did before. RF gain is up. AGC threshold, let's just set it to on. Band is 20. I don't have an antenna connected. I do not have the antenna connected. Okay, volume down. Some of these radios are incredibly quiet when there's no antenna on them. And the speaker, I can't get my ear up to it to hear, you know, hiss and stuff. It's mounted a little too high. Okay, we'll just get this. Oh shoot. Okay, speaker's definitely connected. Everything's happening here. Okay, let's swing this around. Can't hear a thing. Don't hear a thing. Band change. What just popped back here? Nothing. Band change. No crackle. No crackle. But I think if this light is on, or at least is in a high position, then you might not get any sound out of this. So let's make absolutely sure it seems to be doing what it's supposed to do. Okay, maybe the speakers are wired wrong, because I'm the guy who did it. So I'm going to plug in some headphones here. How do these cords get so tangled up? Okay, bring it down. There you go. Headphones. And we hear not a thing. Not a thing. Nothing whatsoever. Not even a hiss. It's just zero. It's completely zero. Okay. So what I will do is I'm going to shut this off by pulling this cord out here. Okay, there we go. Okay, I made a little bit of progress on switch too. There we go. Made a little bit of progress. I'm able to operate this in the shop here with a power supply, and it looks brighter than if I use the internal supply. But the end result is the same. The radio does not work at all. There's no sound whatsoever coming out of the speaker. There are some ways with the audio output completely dead to still figure out if the radio is working or not. That would be like picking up the IF frequencies on an SDR and stuff like that, just to kind of snoop around and see what's going on. That's my power supply overload warning as it just dies out. So I'm going to leave it here for now. Tomorrow we'll pursue this a little bit further and just see if I can't get something to come out of here. I suspect maybe the next place to go, we'll look at the, we'll sniff around for different signals, IF signals and that. Are they there? And we can also look at the output transistors and see if they are shorted or blown or whatever. And we can also look for audio that's approaching those output transistors. Somehow we can pick it off somewhere, I think. I don't know. That's for tomorrow. I'm done for today. So thanks a lot for watching. This is, I think, a really fun radio to get operating. So I'm pretty excited about having one of these. And you can bet 99.9% of it is working. It's the 0.1% I've got to find. Thanks for watching, and have a great day.